Shalom to you and welcome. In this video, I'll be showing you how to find the probability of dependent and independent events. So independent events, from the name, independent means two events that are not dependent of the other. The second one does not depend. So whatever happens to we call outcome of one of them does not affect the other one. So we represent it as if that two events are A and B. Probability of A and B, and means times, equals probability of A times probability of B. But in dependent event, the outcome of one of the events would affect the outcome of the other event. So in that case, probability of A and B is going to be probability of A. Of course, the A is not affected. It is the B, the second one, that will be affected, given that whatever happens to A. Okay. So just a review, remember that theoretical probability is the number of favorable outcome over the total number of possible outcomes. So we need to keep that in mind. So look at the problem. Determine whether the scenario involves dependent or independent, and then find the probability. A box of chocolate contains 8. Okay, we have the 8. Milk and 5 dark chocolates. So the total outcome then is going to be 8 plus 5, which is 13. So that's the total possible outcome. Then you randomly pick a chocolate and eat it, and then you randomly pick another one. So there are two there. So both pieces are milk chocolate. Both are milk chocolate. So the probability of the first one, the probability of picking a milk, times the probability of picking another milk, given that you have already picked milk before. So first of all, the total outcome we know is 13. So it's going to be over 13. You have to find one at a time. So what's the probability of the first one was milk chocolate? We take the favorable outcome for milk chocolate is 8. So it's 8 out of 13 times, then now you have to consider the outcome left. He said he ate it, so it's no longer there. So what will be the total possible outcome after that first one is taken? It will be 12 left. So that will be, you're starting with 12 now. So you see, eating that first one has affected the total probability of the second one. So this would be dependent events. So it will be dependent. The second one depend on dependent. So because if that was not eaten, then the probability, the total outcome will still be 13. So because he has changed it, it is dependent. So and then how much is the favorable outcome for the milk chocolate now? It is only 7 milk chocolates left. So it's going to be 7 out of 12. And then you multiply both in the calculator, we get 56 over 156, which is equal to 14 over 39, approximately 0.359. So there is that chance of picking milk chocolate each of those 2 times. Let's look at another one. You flip a coin and then you roll a fair dice. 6-sided. The coin lands tails up and the die shows an odd number. Okay, so the first one, you have the probability of picking a tail times the probability of picking an odd number. So what's the probability of picking having a tail? Probability of a coin is 1/2. You have 50-50 chance because it's only head and tail, so it's 1/2. And what's the probability of picking an odd number? How many odd numbers are there? First of all, what's the total outcome of a dice? There will be 6 numbers there, so the total outcome is 6. And then probability of picking an odd number. How many odd numbers? 1, 3, 5. So there will be 3 odd numbers. You can pick any of those 3. So what happened in the second probability Is it affected by what happened in the first? No, because even if this one did not happen, the odd will still be 3 out of 6. It will never change. There's no relationship between the rolling a coin and the dice. So you're gonna have 3 over 12, which is simplified to 1/4. Okay, approximately 0.25. We just wonder, is it actually equal? Okay, that's that. So it is independent. Independent. All right, next. You select a card from a standard shuffle deck of 50, so the total outcome there is 52 cards. And then you return it. You need to watch that you return the card. Shuffle and then select another one. Both times you got a diamond. Okay? You know that there are 13 diamonds there. So the probability of getting a diamond times the probability of getting another diamond. Well, first of all, the probability of picking the first diamond is what? There's 13 there. You can choose any one of those 13, a total of 52. Times, okay, since it was returned, what's the total outcome in before the second one? It is still 52 cards. There are still 52 cards there. So there's no change. And how many diamonds are there? Still 13. It did not change either. So we'll still have 13 diamonds and 52 cards. So we multiply those. You get 169 over 2704. And which is simplified to 1 over 16, which is approximately 0.063. So did the probability of the first one affect the second one? No. So because it was returned, so this will be independent event also. Independent.